I'm going to be doing a little video about Markov chains. So this is sort of kind of machine learning. The way it makes it different is we're going to be implementing the whole thing except for hash map, array list, some kind of basic things that we don't need to worry about. But we're going to be implementing really the logic of how this is going to be working. First, I'd like to explain a little bit. Thank you to Victor Powell and Louis Leahy. This is just a website. I'll link it below. It explains it really well. So basically how this works is it uses a finite state machine, or hypothetically, this is how you would imagine it. Machine is a bit of a confusing term to use. I'd prefer box. It's a box of data. It stores one piece of data, that's it. So, and then it transitions to another different piece of data. So for our example, using titles from trending, that would be a string of words. And so each word is a state. And then so a whole title or sentence would be one word transitioning to the next word, transitioning to the next word. And so that would be the finite state machine way of looking at that. How Markov chains comes into play is that depending on one state, that will give you a probability of what state to transition to in the next one. So down here, this is a good example. This is your input data. So you'll see that if it's rainy, there's a higher chance that it'll continue to be rainy instead of transitioning to sunny. And then if it's sunny, there's a higher chance that it'll stay sunny instead of transitioning back to rainy. So then here's the flawed logic would be, well, you just take 50-50, half the days are sunny, half the days are rainy. So just every time just flip a coin and then you can just assign the day that way. But the Markov chain way of thinking about it would be, well, you just find how often this rainy day is transitioning back into a rainy day or transitioning into a sunny day. And then that will dictate each next state. So given that it's rainy, there's a higher percentage it'll stay rainy instead of going back to sunny. So crude diagram here, how we're going to be storing this, our example, a string of words. So you'll have a string here. So this will be the hash map. You'll be mapping a string to a list of strings. And so this list of strings that you're mapping it to is all the strings, all the possibilities of the next word, the next state after this one. Down here in this example, you have Mrs. Smith and Mrs. Simon. Those are both combinations that are in there. So here at this part, you would have Mrs., and then this list would have Smith and Simon. So when you're generating, inputting a Mrs., it will randomly give you a Smith or a Simon. So the only way you will get a Smith or a Simon is if the word before that was a Mrs. So that's how it's depending on this Mrs. to generate the next word. So we're going to have just a class called Markov, and we're going to have a type argument on there. Each string is the piece of data, but I'm just going to make it generic. So what that means is whenever using this class, you can pass a different type in it. You could be an integer or anything like that. And it will do the same sort of logic. It'll work the same, just with a different type of data. The hash map, which I've mentioned. So we're going to map a type of t to an array list, also of, array list also of type t. And this is going to be called map, and I should import that. So those are our imports right there. This right here, this is the key, and this is the value. So every key is a word. And then the value for that key will be all of the possibilities of what comes after that piece of data. In our case, again, strings. So here we're going to say map equals new hash map, and it can imply these arguments from there. Worth noting, these are also type arguments for hash maps. You can make a hash map that mapping strings to numbers or something like that. That's what makes hash map powerful, is because it doesn't matter what type of data. So that's why I'm also using it here. So you could use Markov on any different type of data. And also what I'm going to do is put a null, map that to an empty list. So what that is saying is that the key of null represents the beginning of a sentence. So then this is just guaranteeing that there will be a list there of all of the possibilities that could start a sentence. And then also worth noting, null will represent the end of a sentence as well. So if you put in a key, the next state is determined to be null, then that will end that sequence. So we're going to start off with the add method. So what this is going to do is it's going to take an array of type t, so that will be a sequence of these objects to be analyzed. This dot 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 is basically the same as this, as an array. The reason I'm doing the ... is that instead of having to construct an array, what you can do is just pass all of the different elements that you want to put in this array as different arguments. It's just a nice trick to have. Small correction, you just need to add this line at the beginning of the add function. And what this does is you're getting the list of all of the possible beginnings to a sentence. That is the key for null, and then you're just adding the very first element of this array, int x equals 0. X is less than chain.length x plus plus. All right, so this is looping through every index in this array, and this is an array of type t, so cur equals chain of x. So this is the current element that we're on, index x, and we're going to say if the map does not contain the key for our current element, and we're just going to put a new array list. We're doing that because right here, list of type t next equals map.get cur. So this is going to be the list of the possible states that could come after this one. If x does not equal chain.length minus 1. So chain.length minus 1 is the last element. So for that one, we're going to do something special. But for all the other times, we are going to say next.add chain x plus 1. This list of everything that comes after cur, which is at index x, we're going to add whatever's at x plus 1, so that's a new possibility that could come after this one. But if it is at the end of the array, we're going to add null. Coming after this one of the possibilities is that it's the end of the sentence, null. So this is all stored right in this field right here, so we don't have to return anything, it's just stored there. So now what we're going to do is actually write a helper method for generating these chains. All right, so I'm going to take a parameter of cur, list type t next equals map.get cur. So this is exactly what we said before, but in a different context. So this list is all the possibilities for coming after cur. So what we're going to do is return this next.get. Yeah, we're going to cast this to an int, and I'm going to fly through this a little bit. So what this is it's getting a random element from next. So math.random is a random number from 0 to 0.999. So multiplying that by the size will give you a random number from 0 to the size minus 1. Size minus 1 is the last element of that, and then you cast this to an int, so it's a whole number. Get the element from the random position in this array list, which is perfect. We're going to have a public list t. So this is returning a generic list of this new Markov chain that we're generating. And under the hood, we're going to be making it a array list. I'm going to go up here and say if map.get null.size is more than 0. What this is saying, map.get null, right, that's the beginning of the sentence. So that will give you the list of all the possible startings to a sentence. But if that size is 0, there's no data in there. So there's nothing to return. So we're just going to return null. This type t is going to equal get next of null. Getting next of null will give you the word to start the sentence randomly. So what this is here, well, cur does not equal null. I'm going to write this out and explain it in a second. Add cur, and I'm going to say cur equals get next of cur. And that's done for the class. So now let me explain this real quick. Remember I told you here, if this is the last element in the chain, we're adding null to that list of the possible ones after that. So if you called get next on a word, it's returning null on this, a word or any piece of data. That means that the sequence is over. We're just checking that it's not null, and if it's not, then we'll add it. And then what this does is it says, okay, so that was added, so we'll take this current word we just transitioned to, and we'll get the next one of that. It'll just keep on doing that. For example, get next of null, and we're using strings again, and the first word is the. This is not null. It'll add it to this list that we're returning. Cur is now equal get next of the. Then maybe it'll return cat or dog, and then it'll say, okay, that's not null. Add it to the list, and then it'll get the next one based on that word and just keep on going until it's null, and then we'll return that list. So perfect. That's our class all done. Here I have about 104, I guess, YouTube titles from the trending page. I use some JavaScript DS to do this. So we're going to be writing a class to use the Markov class and read in all that data from that file that I showed you to generate some new titles based on the ones that are put in. So this is going to be public class main. This is just the standard entry point for a program, Markov of type string. It's making a new object so we can add data to it. File data equals new file. As you saw before, it's called data.txt. And then we'll make a scanner. This is not the perfect way to do it, just letting Java know that this could throw an error if this file is not found. You can do has next line, so that's just checking if there's another line in the file to be read. Then what we're going to do is we're going to say Markov.add scanner.next line. So that reads in the whole line. We're inputting an array. So what we're going to do is we're going to split this string by the spaces. And until the scanner has no more lines, you're gonna take each line of that, split it in the spaces, and then add that as a separate chain to our Markov. Instead of just printing out that whole thing, what we're going to do is string generated equals Markov.generate. That's just the generated thing. We'll just format it a little bit. So we're going to say for string s in generated. So this is a for each loop if you don't know about it. So this is the type, this is the variable name, right? And this is the list to loop through. For every one of those, you can just say system.print, not just print, so we're not going to add a new line. S plus a space. If we run this, so you just keep on running this, you'll get some interesting ones. A soccer game happening with Bruno Mars and the official trailer. Top tier clickbait you got here. It's all generated with the power of machine learning, kind of. All right. So I hope you enjoyed this, and have a good one.